Carboxylic acids, the last of our homologous series. This is the functional group, sometimes written COOH, and that's the general formula, which is a bit trickier here because C can be equal to 0. Sorry, N can be equal to 0, so you get HCOOH. That's the first member of the series. That's this, 1 carbon, 3 carbons here, 2 carbons here. What are they called? Got a funny feeling they're the wrong way around. That's methanoic acid, because it's got 1 carbon. Ethanoic acid is this one, isn't it? Because it's got 2 carbons. And propanoic acid is this one, because it's got 3 carbons. Make a little note on your notes about that. It's just a little slip, but we can handle that. Okay? And then butanoic acid, pentanoic acid. You need to be able to name really up to butanoic acid. Important reactions involving carboxylic acids. They are partially dissociated. They are weak acids, aren't they? So in water, this is the functional group. This is just if this could be a H or a CH3 or a C2, a C3H, CH2, CH3CH2, sorry. This basically means the rest of the chain, but this is the business end. This is the functional group, and what happens is it only partially dissociates to give that oxygen minus and a H plus. So you only get a small concentration of hydrogen ions for a given concentration of the acid. So it's a weak acid, isn't it? It's a weak acid. Now, even though it's a weak acid, it will react in the normal way. So with sodium hydroxide, it produces a salt, sodium ethanoate, and water. Acid plus base or acid plus alkali gives salt plus water. With carbonate, it will produce a salt, water, and carbon dioxide. Okay? This is actually not balanced, this equation, I believe. Have a go at balancing this equation. Just noticed it's not balanced. Okay, you probably got it now, hopefully. There should be a big 2 in front of this and a big 2 in front of this. You check it out. Second reaction, it's worth remembering that you produce ethanoic acid from the oxidation of ethanol. So you can produce carboxylic acids by the oxidation of an alcohol. It's not really a reaction they do, it's a reaction they come from. But it's associated with them, so you need to remember it. Third reaction, they are used to make esters with alcohols. Esters are very useful molecules, compounds, because they're volatile, sweet, fruity. They're used in oils, perfumes, and flavorings. When an alcohol and a carboxylic acid come together, this is what happens. This is ethanoic acid. This is ethanol, C2H5OH. Bond breaks, water's produced, and then this funny little molecule comes up. There you go. It's got the alcohol bit here, and it's got the acid bit here. The alcohol bit gives it the first part of the name, ethyl, from ethanol, ethyl. And the acid bit gives it the second part, ethanoate, ethyl ethanoate. Okay, this is called ethyl ethanoate, as I've just explained, because this bit came from the alcohol, the ethyl, and this bit came from the acid, ethanoate. In this case, it was ethanoic acid. You can try and name the following. It's going to be tricky for you because you haven't had lots of experience, but this bit came from the alcohol. So what's the alcohol called with 1 carbon? Methanol. So that would be methyl. And this came from the acid. What's the acid called with 3 carbons? Propanoic acid. So it's methyl propanoate. This time, 3 carbons came from the alcohol, that's propyl. 1 carbon came from the acid, methanoate, propyl methanoate, because it came from methanoic acid. And one last thing here, this bit of the molecule, this C double bond O bit, is called an ester link. This reaction is called esterification. Esterification. I think we mentioned that here. Esterification is a reversible reaction, something to keep in mind. An acid is used as a catalyst, and these molecules contain the ester link. You can identify it in the molecules. Have a look at these. Just to practice the naming. You have to be able to name these molecules. It's one of the requirements for IGCSE. Okay, have a go. And then essential chemistry, 232 and 233.